Hello, you're welcome to our topic 2. Yes, and this is linear functions. And linear functions, under this we are specifically going to look at how to plot graphs. And a graph is a visual representation of information showing how quantities vary or how one quantity varies with another. And the most common method of showing this is using a pair of references known as axes, or two lines drawn and they always meet each other at an angle of 90, and these are commonly known as the Cartesian axes. So for these lines, the horizontal line or the horizontal axis is always labeled as the x-axis, and the vertical axis is always labeled as the y-axis. And the point where these two lines meet when they are both 0 is what is known as the origin. Please, they both meet when they are 0, they both meet at the origin. So the x values have scales that are both positive to the right and negative to the left, or if we remember very well our number line. So the way the number line is drawn horizontally, it has both positive and negative values. Likewise, the x-axis always has positive values on its left and then negative values, on its right and then negative values on its left. So likewise, the y-axis also has both positive and negative values. The positive values are up and then the negative values are down the origin. So coordinates are written with brackets with a comma in between, and the first number is always the x-axis and the second number represents the y value. So the first number is the x value and the second number is the y value. So this is an example of a line graph or a Cartesian graph. So our horizontal line is the vertical axis, and our vertical line is the y-axis, and the horizontal line is the x-axis. And a point A is drawn at a point. We can see when x is 3. That's why we have 3 as the first number here, and then the y value is 2. So this is how we mark off a point on our graph. So I want you to try out this, to try and plot this graph, and please note that we need a relative to have a scale. So there are some rules that we follow when drawing our graphs. And the first rule is that a graph should have a title clearly explaining what it is about. Please note that such numbers, a graph without a title wins an automatic 0. So it should always have a title that clearly illustrates what, or talks about what is illustrated. Then you should choose scales such that the graph occupies as much space as possible, and we always talk about 3/4. It should, or at least cover 3/4 of your page. And then you should choose a scale such that interpolation is made easy. So we usually advise scales of whole numbers, for example 1 centimeter, or one representing 1 unit, or 1 unit representing 1 centimeter, or 2 units representing 1 centimeter, or 1 centimeter representing 10 units, or 1 unit representing centimeters, and so on. I shouldn't expect a scale of where maybe 1 unit represents 0.008 units representing 3.55 centimeters or meters or kilograms. You should choose scales that are easy to work with. Then scales need not start at 0, because when you start at 0, we shall have an accumulation of points within a small area of the graph paper. So the coordinates should be clearly marked. For example, if we check our previous graph, we see that the coordinate point A is well marked off. This is using a dot. We can even have a circle on a dot or a cross. So each point that you're plotting on the graph should be well marked or easily identifiable. Then a statement should be made next to each axis explaining the numbers represented. So on your horizontal axis, what are you representing, and the vertical axis, what is represented. So those statements should be clearly stated, and then sufficient numbers should be written next to each other without cramping. So make your graph look tidy. So an example here, if we want to plot a graph of y is equal to 4x plus 3 with a range of x from -3 to +4. So if we want to find, and then we are supposed to find the value of y when x is 2.2 and also find the value of x when y is -3. So what we need to do is to always get the corresponding, because the values of x are given, we are ranging from -3 to +4, but we don't have the respective or the corresponding values of y. So what we need to do is to always first find the corresponding values of y to the given values of x. So we shall start with our -3. So when x is -3, what is y? So we do simply come to the given equation and then substitute the value of x. So when x is -3, we shall multiply -3 times +4. Remember, when we multiply a negative with a positive, we get a negative. So -3 times +4, we shall get -12, but we are adding a 3 to it. So -12 plus 3 will give us a 9. So the next value there will be -2. When x is -2, what is y? So we come and replace x with -2. So 4 times -2 will give us -8. So -8 plus 3, we shall have a -5, and that is why we have a -5 here. So when x, the next value is the range of x's are here, the next value is -1. When x is -1, what is y? So we come to our equation again and replace x with 1. So -1 times 4 gives us -4. -4 plus 3 will give us a -1. That's why we have a -1 here. So you do the same up to when x is equal to the last value, which in this case is 4. So when we replace 4 with x with 4, we multiply 4 times x, getting 12. So when we add 12 to 3, we get 4 times 4 gives us 16, So when we add 3 to 16, we get a 19, and that's the 19 that is here. So therefore, our corresponding values of y when x is -3, y is -9, -2, -5, and 4, 19. So that is always the first step. So these are the corresponding coordinates now. So when it is -3, -9, -2, -5, and so on. So we come and plot our graph. So you remember when x was -3, y was negative. When x was -3, let me go back a bit. When x is -3, y is -9. So we need to confirm when x is -3, y is -9. We see the positive values of y are up and the negative values of y are down. So, and we see that there is a clearly demarcated scale on the y-axis. Each box represents 5 units. So from 0 to 5, then 5 to 10, 5. So the scale is consistent. And then on the negative axis, the scale is 1 unit representing 1 unit, or 1 box representing 1 unit. And please note that the scales don't have to be the same. The y-axis scale and the horizontal axis scale do not always have to be the same, though they can still be the same if you choose to. That will depend on the nature of the graph. So when our x was -3, our y was -9. This is the point. When it was -2, our x was -5. So the scale is here and so on. And lastly, when x was 20, the y was 19. So we make the points and then after join the points, and this is giving us a straight line. So they have told us to read off x when y is -3. So we go to y, -3 is here. So what will be x? Our x will be -1.5. Then also to read off y when x is 2.2. So 2.2, we extrapolate up to when we reach the line. So the value there of y is 11.8. So after knowing how to plot our graph, we can now determine the gradient, the intercept, and then the equations of graphs. So a gradient of a line, or usually known as the slope of a straight line, is the ratio of the change in the value of y to the change in the value of x between any 2 points on that line. And in scenarios where if x increases and y also increases, for example, in the first graph here, as x increases, y also increases, their gradient will always be positive. And then if x reduces and y increases, or if y increases as, or if y reduces as x increases, the slope will always be negative. And then if one change in one value is not affected by the other value, we shall always have a zero gradient, or there will be no change. For example, here in part C, we see that x is increasing but y is constant. So there, that change will always be negative. So similarly, it could even be y increasing but x being constant. The gradient there will still be 0. So we can read off gradients and intercepts from the line graph, but before we go to that, we are going to see how a gradient is read off from, or is got from, a straight line. So we always construct a right-angled triangle such as ABC. We are going to use graph number 1. So we construct a right-angled triangle, and we've said that a gradient is a change in the y value over the change in the x value. So we see that if our chosen points A and B, the y value changed from 3 to 7. And then the x value changed from 1 to 3. And we've said that the gradient is the ratio. So we divide the change in y by the change in x. So what we do, the change in y will be 7 minus 3 divided by the change in x, which is 3 minus 1. So 7 minus 3 will give us a 4, and then 3 minus 1 will give us a 2. So that's why we have a 7 minus 3 here over 3 minus 1, and the answer is a 2. So therefore the gradient of the line is, that particular line is 2. So that leads us to equation of a line graph, and the general equation is always expressed as y is equal to mx plus c. And in this equation, m is always our gradient and c is always the intercept, or the point where the line cuts the x-axis. So that is, the line cuts the y-axis. That is always known as the y-intercept. So the point where the line cuts the y-axis is our C. So From our general or generic equation, m is always the gradient. So meaning from this equation we can already read off the gradient instead of calculating it the manual way. So you can either go this way or just read it. If you have an equation of the line, you can just read it off. So our 2 is the gradient of the line. So we see that this is the equation of the line, y is equal to 2x plus 1. So, and we've calculated or we've confirmed this by calculating the change in y over change in x, and we got a gradient as 2. So we can even just read it off straight away. Then the y-intercept, the point where the line cuts the y-axis. So you see it cuts it at 1. So our c is always the y-intercept. So I think that proves our equation. So we do not need to analyze or to calculate the gradient and the y-intercept in case we have the equation of the line. So we have some examples here that if mx plus c, y is equal to mx plus c, then this will be the gradient. So if we have 9x plus 2, our gradient will be 9 and our intercept will be 2. Then if the negative, that we have a negative 4x and 7, the negative 4 will be our gradient and the 7 will be our intercept. Then if we have y is equal to 3x, that means we have a plus 0 here. So the gradient will be 3 and the y-intercept will be 0. Yes, and that is it. Thank you so much. Please stay safe.